Hey everyone! So this is the first video for chapter 4. So we're looking at for a quadratic functions, something that you've likely done since year 10, definitely would have done it last year. Hopefully this is just revision for you. There is quite a bit in 4A to get through because quadratics is quite a significant part or a significant, I guess, equation, or the parabolas are significant graphs in the methods course. So we need to make sure that you understand how to not only do things like transformations, but also things like completing the square, the quadratic formula, understanding what the discriminant is, and so forth. Now there are quite a few questions here. I'm not going to film doing all of them, otherwise this video would probably go for about an hour. So I'm going to try to keep it under 30 minutes, and my other videos I'm going to aim to do the same. All right, so let's get started. So transformations of parabolas. Now transformations we've done before. Hopefully it's just revision for you. Remember, I'll just get my little cursor ready. Okay, we've got the value of A. Yellow doesn't look too good on green, but I'm sure you can see it. So if A is greater than 0, the graph has a minimum point. So that just means the type of graph you have, and I might just quickly draw it over here, is your basic parabola, which looks like that. Okay, so that's what it means by a minimum point. Your minimum point is here. Now, if A is less than 0, the graph has a maximum point. So that means it's a upside down parabola, and there is your maximum turning point. All right, and I might just highlight that as we speak. All right, the vertex is the point HK. Okay, so remember H is here. That minus does not belong to the H. It's just the general form of the equation. So hopefully by now you're okay with that, and there's K. So what that means, your turning point, or your vertex, which is the same as your turning point, is HK. And here it's HK. Okay, so as long as you've got your equation in what we call turning point form, you'll be able to read off what H and K are. And that's why it's called the turning point form, because H and K are your turning points. Now, if it's not written in this form, in turning point form, you can always complete the square to put it into this form. You don't have to do completing the square to find the turning point though, so we're going to do a few examples of them as well. All right, the next dot point, the axis of symmetry is x equals h. Basically, what that means is axis of symmetry. Symmetry means it's the same on both sides. So if I was to cut myself, or maybe draw a line down the middle of my body, so starting at my head and going all the way to my feet, it would be the same on either side. So that's what your axis of symmetry is. So you can see there, I'm just cutting them at x equals h, so h being your x coordinate of the turning point. So the next point is just referring to your transformations. Okay, so we know the transformations, A being your dilation factor. If it's negative, it's been reflected. H is your horizontal translation, so how you've moved along the x-axis, and K is your vertical translation, how you've moved along the y-axis. All right, let's move along. Axis of symmetry. So this is what I was saying before, is you don't need your equation to be in turning point form. So here you can see it's in polynomial form or expanded form. Okay, if it's in expanded form, you can find the x-coordinate of your turning point, which is the same as your axis of symmetry. So that's why it's under axis of symmetry. So as long as you can identify A, which is the coefficient of x squared, B, the coefficient of x, and C, your constant, you can get the x-coordinate of your turning point. Okay, so you don't have to always complete the square. Now, when you've got your x-coordinate of the turning point, to get your y-coordinate, remember, you just substitute it back into your equation. So you'd find a value for x, okay, so just by doing negative b onto a, and then to get your value of y, you just substitute that value of x back into your equation. So we'll do a few examples of that. And that's what it just says underneath. I didn't even realize. Okay, the next one, graphing quadratics in polynomial form. All right, so when it's in polynomial form, so remember I did that before. Where are we? They're highlighted in yellow. Let me just underline it. Sometimes I point to things, well, I did last year when I did videos, assuming that you can see my cursor, and I realize you probably can't see my cursor. All right, so when you're graphing any quadratic, you should always find whether there's any axis intercept. So there will, unless your graph is restricted, you'll always have a y-axis intercept. X-axis intercepts, it depends on what's happening with your graph. So I might just show you quickly here. All right, so, and we'll do a few examples of these. So you might have a parabola that goes like this, okay? So you can see it's crossing the x-axis twice, okay? So it's got two axis intercepts. If it's sitting on the, so I might just write that on to here, two x-intercepts. All right, let's draw another one. All right, there we go. All right, if it was sitting, oh, I didn't want it red. Oh, sorry. There we go. Oh. I press Control Z, it doesn't go away. All right, so let's do a parabola like that. Okay, that is sitting on the x-axis, so that means it has one x-intercept. And then we can also have the scenario where it doesn't cross the x-axis. So we can either have a positive parabola that's been shifted up. Okay, so see how it doesn't cross? There's your turning point. Or you might have a negative parabola that's been shifted down, something like that. Okay, so it doesn't cross, no x-intercepts. And if you are doing where are we? All right, if you are doing it in turning point form, all right, as you can see here, let me just put a little square around it. Now, see how A is positive, okay? So A doesn't necessarily have to be positive, but let's just say it's a positive parabola and it's been shifted up by K. All right, so that means it's not going to have any x-intercepts. Basically, if this plus, or this is a plus, if you're got a positive parabola that's been shifted up, you're not going to have any x-intercepts. So if you've got it in turning point form, eventually, or even now, you should be able to tell whether you've got x-intercepts or not. And you will know, even if you didn't look at the equation, but you'll eventually know because you'll be taking the square root of a negative number. All right, so which you can't do to get a rational answer. So you can either look at it, and if it's a positive parabola that's been shifted up, no x-intercepts. If it's a negative parabola, so A is negative and K is also negative, so it's a negative parabola that's been shifted down, like this scenario here. Oops, I just realized you can't see my cursor, so this one here, no x-intercepts. All right, so you'll eventually be able to look at them and say, well, this is what it is or isn't. All right, so your y-axis intercept, we let x equal 0. Okay, so I'm just going to put that there. So remember x equals 0. Find the x-axis intercept, so we let y equal 0. Find the equation of the axis of symmetry. So that's only if it's in polynomial form. So that's going back up here. Whoops. All right, finding, so I might just highlight it using this. And then to find the coordinates of your turning point, obviously your x-coordinate is the same as your axis of symmetry, or your x-coordinate of axis of symmetry, and then you just substitute it back in to get your y-coordinate. Oh, I have deleted. How did I do that? Where? Oh, there it is on the other. I was wondering how that happened. There we go, completing the square. So as I said before, to get it into turning point form, you need to be able to complete the square. Completing the square, hopefully you've done since year 10. It's just a process to go through, taking a polynomial into turning point form. So there's instructions here, which are very slightly different to how you may have been taught, which is the same thing. So we do the, b over 2, and then we square it. So if we were to square b over 2, we get b squared over 4. So you can see that here. I know in some textbooks they don't write it as b squared over 4, they write it as b over 2 squared. It's exactly the same thing. To complete the square, take out a as a factor and then complete the square inside the bracket. Now, you can take anything out as a factor, but I would say if it's too complicated to complete the square, I probably wouldn't complete the square. Completing the square is good for seeing what the transformations are. It's good to see what the turning point is, but I would only ever do it to see what the transformations are, really. I would probably just use the quadratic formula, to be honest. Or you can also factorize a quadratic if it's an easy one to factorize. Let me just think what else. Yeah. So here's the quadratic formula. So you can apply the quadratic formula to any quadratic, no matter how simple or how complicated it is. Now just remember your discriminant is here, b squared minus 4ac, so that's on the next page. This tells you how many solutions there are. So when you think about it, if I was to substitute everything into the quadratic formula, this square root, if I was to take the square root of a negative number, I'm not going to get an answer. So you can see if I just quickly go here, if your discriminant, which is here, if your discriminant was less than 0, there are no real solutions. Okay, so you need to remember that. There are no real solutions. All right, now if your discriminant was 0, you're going to have the square root of 0, which is just 0. So you're not going to have this plus or minus 0 because it's the same thing. Plus 0 and minus 0 is exactly the same. So that's why when we've got, if the discriminant is equal to 0, there's one solution. And then that brings us to the other possible solution. If your discriminant b squared minus 4ac was greater than 0, so it was positive, you would get two answers. So let's say if we were doing the square root of 4, the square root of 4 can be positive 2 or negative 2. So that's why there's a plus minus there, which I might just highlight. I used my cursor, but you probably didn't see it. Now, the quadratic formula gives you your x-intercepts, so that's why it's a good idea to think about the discriminant first, or you could probably do your substitution and then realize whether you can keep going or not. Don't think, oh, I can't do the square root of a negative number and think you've done something wrong. Remember, that's just a parabola that doesn't cross the x-axis. Your your x-intercept, so if I draw my very wonky axes there. All right, so let's say I've got a parabola and I've got my x-intercepts here and here. Your turning point is directly halfway. So you can find that turning point. You can do negative b over 2a like we said before, or you can just add your two values together and divide it by 2. So you can just remember that the x coordinate of the turning point is halfway between your x-intercepts. All right, so we talked about the discriminant, which is great. All right, so let's have a look at a few of these questions. So we're going to do a bit of sketching. Now, the first two, A and B, are in turning point form. All right, so you don't have to do this, but it's a good idea to identify AB, not AB. A is 2, H, remember, is -1, and K is also -1. So your turning point is at HK. which is -1, -1. All right, so that's your turning point. What we also need to sketch it is our x-intercept. So I can see, remember how I said it's important to think about your parabola? This is a positive parabola that shifted down 1. So I do have x-intercepts. I actually have 2 x-intercepts. So your x-intercepts are found by letting y equal 0. So we're just going to do 2x plus 1 squared minus 1 equals 0. And then we just solve. So I'm going to skip a few steps just because I want to. So I've brought that 1 over and then divided it by 2. And then I'm going to take the square root of both sides. So I'm going to have a positive and negative 1 on root 2. Because I take the whole square root of a half. So the square root of 1 is 1, the square root of 2 is root 2. And then I've got x equals -1 plus 1 on root 2 and -1 minus 1 on root 2. All right, so now for your y-intercepts, we let x equal 0. Okay, so we've got 2, 0 plus 1 squared minus 1 equals y, sorry. Probably should have put the y on the other side. All right, so 1 squared is 1, 2 times 1 is 2, so 2 minus 1 is 1, so y equals 1. All right, so graphing it. All right, there we go, our axes. All right, I have a turning point at -1, -1. Now you can see I'm not really using the scale here. So there's our turning point. Now I've got -1 plus 1 on root 2 and -1 minus 1 on root 2 and a y-intercept at 1. So I'm going to put that in there. With my x-intercepts, if you don't know what 1 on root 2 is, just think, well, where on my axes should it be? So root 2 is somewhere between 1 and 2. So I think it's around 1.4. So basically you're going to have 1 divided by 1.4. So you're adding a proper fraction. Sorry, I'm trying to get you to get your head around it, but we're going to be doing -1 plus a proper fraction. So we're going to actually still be on this side of the axis, and you can also see that because of the y-intercept. I'm not going to cross that and then have to come back. All right, and as long as it's symmetrical. All right, and you've got this one here, so I might just put that up there. Okay, so we're just going to try to be as accurate as possible, which is really hard to do on the computer. There we go. All right, and oh gosh, that's terrible. All right, and I'm just going to put my x-intercepts in. So this side is going to be -1 minus 1 on root 2, and this side is going to be -1 plus 1 on root 2. Now, with the square root of 2 on the denominator, some of you might be thinking, oh, should I rationalize the denominator? You can. I would just leave it as 1 on root 2, but you should know that's the same as root 2 on 2 if you want to do that. All right, so we've got the important points. I've got my x-intercepts, my y-intercept, and the turning point. My domain hasn't been restricted, so I can just leave it like that. All right, let's move on to the next one. All right, so again, identifying A, H, and K, it's in turning point form. So A is -2, H is -1, and K is 4. So for this one here, it is a negative parabola because A is negative. Okay, just because the 4 is written at the front, it's the same as if it was written as +4 at the end. So you need to be familiar with that. So a negative parabola that's shifted up 4. So we are going to have two x-intercepts. I'm just going to write the turning point now because it's a bit easier. So the turning point is at -1, 4. All right, remember for your x-intercepts, we let y equal 0. And for your y-intercepts, you let x equal 0. All right, I'm going to pause it and finish it. And you can maybe pause the video as well and have a go at doing it yourself and then check how you went. All right, so here's the answer for B. I'm just quickly going through it. Hopefully you got your x-intercepts correct. Now, the square root of 2, I know, is roughly around 1.4, but if you're ever unsure, just go close to your perfect squares. So the two perfect squares between 2 are the square root of 1, which is 1, and the square root of 4, which is 2. So the square root of 2 has to be somewhere between 1 and 2. So that means that we're going to be on the positive side of the x-axis. Okay, so you can see here. Got your turning point, and then the y-intercept is at 2. All right, so for question C, all right, this time we don't have it in turning point form. So you can see here we've got 4x squared plus 8x minus 7. So we do have a non-monic quadratic, which just means the coefficient of x squared is not 1. In this case, it's 4. Now, as I've said before, you can use the quadratic formula for absolutely any quadratic, but we're going to do completing the square for this one, just so you can have a little bit of practice of completing the square, but also so you can see, maybe have a little bit of practice. We'll see how it links to the turning point form. All right, so let's look at the first two terms I've got here. All right, so 4x squared plus 8x. So I can see I can take out the common factor of 4. So I'm going to go ahead and do that. So then I'm going to be left with x squared plus 2x in the brackets. Now I know that x is also a common factor, but we're merely doing this to complete the square. And to enable us to complete the square, I do need the coefficient of x squared to be 1. So I'm taking out the 4 there, and then we've got minus 7 on the end. Now, when I complete the square, I'm going to leave the 4 out the front, and then we've got x squared plus 2x. Now I add the coefficient of x, which is 2, divided by 2, and then square it. And then whatever I add, I also have to subtract, so I'm going to subtract that as well. So it's going to be 2 on 2 squared. If you wanted to, you can go ahead and write what it is. And then we've got minus 7. All right, so what these first 3 terms become, this is how why you complete the square. Because what I have in red there is x squared plus 2x plus 1 squared, which is just 1. So when I factorize that, I'm actually left with x plus 1 all squared. Okay, so that's what is factorized here. X squared plus 2x plus 1 squared becomes x plus 1 squared. So if I was to expand that, I would get what I've got on the previous line. Then I've got minus 1. I'm going to close that bracket, minus 7. I did keep the red there so you can see what is happening, but I do have 2 brackets. So that 4 gets multiplied through both the x plus 1 squared and the minus 1, which is minus 4. And then we've got minus 7. So just tidy it up a bit. Oh, tidy it up, she says. Her x looks terrible. All right. It's good by the time you're in year 12, you're probably used to your maths teachers not being great with their numbers, especially on the computer. All right, so there's our equation in turning point form. So same equation, I've just rearranged it and put it in turning point form. So I can see there what my turning point is. I can see the dilation factor here of 4. So I can see it's being translated 1 unit in the negative direction along the x-axis, 11 units down. Okay, so putting it in turning point form does help you see the transformations. All right, so let's draw this graph. So our turning point is at HK, so that's going to be -1, -11. We need to find the x-intercept, so you'll let y equal 0. So your x-intercepts, so we've got 4x plus 1 squared minus 11 equals 0. So I'm going to maybe just cheat a little bit and just do a few things in one go. So x is equal to that 1's going to come over as -1 plus, now the square root of 11 can just become square root of 11, but the square root of 4 becomes 2. And then your other solution is -1 minus root 11 on 2. Now what I've just got there for your x-intercepts is what you would get if you did the quadratic formula. All right. And now your y-intercept, which is quite easy, because when it's in polynomial form, it's just your constant, okay, which is here, -7. So, yep, oops, -7. All right, so let's quickly sketch that. Down we go, and I'm very conscious of the time, so might have to turn this into 2 videos. All right, so turning point is -1, -11. Right, so it's down there. Your y-intercept is at -7. And then our 2, oh gosh, this is going to be complicated. Square root of 11. All right, so if I might just do this down the bottom just as an aside, because before we did the square root of 2 and you're probably like, okay, I get what she's talking about. Now the square root of 11, you got to think about your perfect squares. It is between the square root of 9 and your next perfect square, which is the square root of 16. So it's going to be somewhere between 3 and 4, and probably closer to 3 than what it is 4. So when you're sketching it, you don't have to know exactly what the square root of 11 is, but I know it's going to be 3 point something, and then we're dividing that by 2. So just an added complexity. But because of this y-intercept, I know I'm going to be on the other side of the axis anyway. So I can just go, oh gosh, that's probably not the most accurate graph, but let's stick with it. So I've got -1 plus root 11 on 2 and -1 minus root 11 on 2. Although my 11s don't look like 11s, I apologize. But they are 11s. Okay, they're not n's or pi's. All right, question D. I'm going to use the quadratic formula just because it's written a little bit differently, and I can't take out, well, I could take out a factor. I just can't take an integer as a factor. So I'm going to use the quadratic formula. So identifying A, B, and C. So remember A being the coefficient of x squared, in this case it's 2. B is your coefficient of x, in this case it's -5, and C is your constant. Now it's not written there, so it's +0. So your value of C is 0. Now your discriminant, if you wanted to quickly do that, you can, but I'm just going to go straight into the quadratic formula. So x equals, I do have it in front of me, so but I'm going to write it down for you. It's always a good idea to write the formula just to get it stuck in your head. All right, so we're just substituting A, B, and C in. So B is -5. Now, negative numbers, remember we love a little bit more, we give them a hug. So I've got B is -5. So everywhere I see B, I'm going to put brackets just so we don't get make any mistakes. All right, so minus 4 times A, which is 2, times C, which is 0. So you kind of see what's about to happen there. And then over 2 times A, so 2 times 2. All right, negative 5 is positive 5. Then under our bracket, so this minus 4 times 2 times 0 is just going to be 0. So then we've got negative 5 squared is 25. So the square root of 25 is 5 over 4. So I'm going to be left with 5 plus 5, which is 10 over 4. And then 5 minus 5, which is 0 over 4. So, 0 over 4. So x is equal to 0. So your two x-intercepts are 10 over 4 and x equals 0, or x equals 10 over 4 and x equals 0. I'm just trying to think. You're probably thinking, oh, she doesn't even know what 5 plus 5 is. I'm actually thinking as I'm going. All right, so if we were to graph that, I know we haven't got the turning point yet, but if you've got an x-intercept of 0, your y-intercept will also be 0, so which we also found from the equation. So we've got there at 0, 10 over 4 is, oh my gosh, I'm having so many blanks today, 2.5. Okay, so I'm going to put that over here. And I'm just going to leave it as an improper fraction, 10 over 4. Now remember, your turning point is halfway. So I can say, well, 10 on 4 divided by 2. Now, if you're struggling with that, remember when you're dividing fractions, you keep your first fraction, change your division to a multiplication, and then flip. So we're going to have 10 on 8 is going to be our halfway point. Another way of getting that, remember, is your turning point is at x equals negative b on 2a. So b is negative 5, so negative 5 is 5, and 2 times 2 is 4. Okay, so you can see it's the same thing. 5 on 4 is the same as 10 on 8. All right, and then to get your y-coordinate of the turning point, we just substitute it back in. So, and then I'm just trying to do that. I'll do 5 over 4 squared minus 5 over 4. All right, so when you square a fraction, you square the top and the bottom. So we're going to have 2 times 5 squared is 25. Oops, why did I write 24? Just bear with me. And 4 squared is 16. All right, 5 times 5 is 25. And then, sorry, we don't need to multiply the denominator, over 4. 2 times 25 is 50. We're going to have 50 on 16 minus 25 on 4. Now, if you wanted to do this subtraction, you must have the same denominator for your fractions. So I've got to change this 4 to a 16. So I did that by multiplying it by 4. So I do it the same to the top. So 50 minus 100. So we're going to have negative 50 over 16. And then ideally we should simplify that, but I'm running out of room. So that is, how many times does 16 go into 50? So we've got 1, 2, 3. So I'm just going to do it down. Yeah. All right, ideally I should have them simplified, so I might actually do that. So this one down here, negative 25 on 8. And the 10 over 8, I'm going to change that to be 5 over 4. And then the 10 over 4, I'm going to change that to be 10 over 2. No, sorry, 5 over 2. All right, with question E, I will leave it up to you whether you want to use the quadratic formula. So we used the quadratic formula in the previous question to get your x-intercepts. You can factorize that. You can complete the square. I find completing the square when your coefficient of x, is not a factor of your coefficient of, your coefficient of x squared is not a factor of the coefficient of x. So negative 2 and 9, you would have to take out a common factor of, let me just think. Take out the common factor of negative 2, okay, because we do want to get x squared on its own. This is if you want to complete the square. When you're doing the 9 over x, however, because we're taking the negative 2 out as a common factor, we will just write the coefficient of x as negative 9 on 2. So that just means when we multiply through that negative 2, we're left with the positive 9. And then we can just have the plus 11 on the end. So I might just tidy this up a little bit. So negative 2x squared minus 9 on 2. And then if you're completing the square, remember we complete the square with these first two terms. So we add 9 on 2 squared, then we subtract 9 on, sorry, let's not get the negatives incorrect. So it should be negative here, but when we square it, it doesn't make any difference. But it's better to be correct. All right, and then we've got the plus 11. All right, so negative 2, I wasn't going to do this, but look at me, I'm already doing it, x squared. Oops, I just realized I've made a mistake. Just give me 1 sec to quickly fix it. Because I did the, I'm just going to fix all this up, sorry. Because it's the coefficient of, sorry, so many blanks in my head right now. All right, so the coefficient of, why haven't I put the x there? All right, so the coefficient of x is negative 9 on 2. So I've got x squared minus 9 on 2x. So then we add the value of b divided by 2 all squared, and then we subtract that. This is where it's going to be a little bit tricky. And I'm going to close my brackets and then add 11. Now on the side here, I'm just going to do 9 on 2 divided by 2. So remember, we keep the first fraction, we change our division to a multiply, and then we flip. So that's going to become 9 on 4. So what I might just do, just to tidy it up a little bit, because there's a lot going on, is just change that negative 9 on 2 over 2 to just 9 on 4. And I'm going to do the same here. All right. Now we can factorize these terms. Now the reason I keep this in a bracket and I don't worry about squaring it, because negative 9 on 4 becomes our factor. So we're going to have x minus 9 on 4 squared. Now we can do 9 on 4 squared. So 9 squared, negative 9 squared is 81. And then 4 squared is 16 plus 11. All right, multiply, whoops, got a bracket there. Multiply everything through by that negative 2. So negative 81 on 16, when I multiply that through by 2, I'm going to have negative 81 on 8. And then plus 11 on the end. Now, sometimes it's easier just to rewrite it now with the same denominator. So 11 is the same as 88 on 8. And I'm just going to tidy that up. This is a very tricky one. All right, so negative 81 plus 88 is going to be 7 on 8. All right, I just checked my answer again and I realized I made a mistake. I don't know whether you followed it where I made it. All right, when I multiplied through here, silly Billy. All right, I was multiplying by negative 2, which made this not negative 81 on 8, but positive 81 on 8. And then I can still write 88 on 8. All right, so 81 plus, so much easier to do the negative, but anyway, 80 plus 80 is 160, and 1 plus 8 is 169 on 8. I'm going to check my answer again. All right, good. That's correct. Now, this is a negative parabola. Okay, we've been dilated by a factor of 2 from the x-axis. It's been shifted along the x-axis by 9 on 4 in the positive direction, and it's gone up 169 on 8. All right, so we can read those transformations. We can also read the turning point. So I'm going to do that over here. So our turning point is at 9 on 4. 169 on 8. Oh my gosh, your x-intercepts is going to take me a while to do them, and I don't have enough space. So I might just do them separately. I do know the y-intercept though, that's easy. Do we all know what that is? Just your constant, which is 11. Yeah, so to get your x-intercepts, we just need to let y equal 0, but I'm just looking at it now and I'm like, that's just going to take up too much space. So go ahead and do it. And why am I writing y-intercept? So we're finding the x-intercepts and then we'll graph it. All right, so I just sketched it. So hopefully I sketched it correctly. So let's draw it. All right, so I've got an x-intercept of negative 1 and 11 on 2. All right, so your y-intercept is at 11. Now 168 divided by 8 is going to be, oh my gosh, I can't even think of where that might be. Well, 160 divided by 8 is 20, so we're around 21. So we're going to be needing quite a long y-axis. All right, and then what is the 9 on 4? So 2 and a bit. All right, so let's just sketch it. Oh gosh, this is terrible. All right, so 11 on 2, negative 1. What was this one? 9 on 4. And then up here we had 169 on 8. All right, I sketched it on this program, so I'm just going to maybe do it again on here. It's going to let me. Okay, so I just need to change my y maximum. I'll change that to 22. Should be good to see now. All right, so there's our maximum. Okay, so I can see there I've got those points correct. And then our x-intercept, sorry, and then our y-intercept there. All right, so a little bit nicer on that graph than what mine is, but all my points are correct. All right, have a go at doing F, G, and H, and I. So some of these you can take out a common factor. I'm already looking at I, and you can take out -2 as a common factor. I'm just conscious that this video is now, I think, 40 minutes long. So I'm going to stop there with all the sketching. You do the sketching, and then in the next video, we're going to talk about question 2. All right, bye.